Okay, so we're going to close out this chapter by looking at some animations of the Longshore Drift and other processes. We have to do it as a screen capture, and here we are opening the PowerPoint. And so this is the beach drift that we talked about, the longshore current, and we said we have a meandering motion because the waves are coming in. They are trying to get parallel because of our shallow water equation. Remember, square root GD. So the wave speed of the crest or the wave form away from the beach is faster because it's in deeper water. Close to the coast is slower, so the waveform is going to swing around and try to get parallel to the coast, but obviously it doesn't get all the way parallel. So it swash is going at an angle up the beach, the berm, the sand face. Water soaks in, and then gravity makes it flow down directly. So you have this kind of zigzag motion that we talked about. So you can see this animation here, and you can see this. I have lost my cursor, but you can see the movement of the beach face being shown here. Okay, so the next one shows hard stabilizations like groins. So here is groin. What happens when you add a groin? You have a longshore drift in this direction. So sand is going to start building up against the face of the groin on this side. This side is starved because you have stopped this longshore drift, but that is going to get eroded and build up over here, and so on and so forth. Eventually, if you leave it, this is going to reach all the way here and then flow over, right? So there is no new sand coming in because of any of this. You are just modifying the natural flow of sand as a temporary measure, and then it requires after some time to go and put the sand back. Like if it piles up all on this side, eventually you will have to bring it back onto this side, and so on and so forth. Jetties are slightly different. You have two structures perpendicular to the beach face. So you have again beach drift building up on this side, eroding on this side. Here it's a bigger problem because if it flows over and goes here, you have a harbor, and you don't want sand coming into the harbor. So eventually you will have to dredge the sand from the harbor and put it back out, as has been done in Santa Barbara and Santa Cruz and so on and so forth. Okay, the breakwater, which is parallel to the coast, you can see it is created knowing how the wave energy works in this area. It is used to create a wave shadow behind it, and because you have created a wave shadow, the erosion and the longshore drift is affected. So the drift is going to be reduced because the waves are reduced. So you're going to have deposition of sand behind the breakwater. So eventually the breakwater is going to be the harbor is going to be closed. So again, you need some mechanism to take it out. So these are simple animations, but obviously not trivial because people keep doing these. So here is the image of the Santa Monica breakwater before it was built and after it was built. So you can see the flow of sand has been affected here already, but now the longshore drift is this way, so it's accumulating here. After the breakwater, you created the wave shadow and you accumulated a lot of sand. It was already becoming a problem, but then it got blown away in the 1983 El Nino year. Okay, so that's kind of the short chapter on coastlines, and we learned a few things. In the next chapter, we will move to marine pollution, a big problem. So we will look at more carefully at what are the specific issues affecting the marine water quality. Okay, how life is affected, how water quality is affected, and so on. So see you in the next chapter.